kubaha ikaze muri studio za Ishuri TV. Ishuri TV ni YouTube channel ibagezaho amasomo agiye atandukanye, amasomo ajyanye n'iby'ikoranabuhanga, amasomo ajyanye no gutegura amafunguro, n'amasomo ajyanye n'ibicurangisho bya muzika, gucuranga piano, gucuranga gitari n'andi masomo agiye atandukanye. Tubanje kubashimira mwe mwese mukomeje kudukurikira, muduha comment ibyo tukwiye guhindura n'izindi comment zigiye zitandukanye, munasharinga, mukora na subscribe. Turabashimiye aho muri hose ku isi, by'umwihariko abashuti bacu bari mu Maputo, Andre, Claude, mwese mugubwe neza, kandi turasuhuza n'abandi bantu, abatekinisiye bo muri King Electronics, Jeremy gubwa neza, Haji mukomeze kugubwa neza, kandi mukomeze gufashwa n'amasomo ya Ishuri TV. Uyu munsi turaza kwiga kuri relay switch. Relay switch turareba types za relay switch, turebe operation za uko working principle ya relay switch, turebe na applications aho dushobora gukoresha relay switch n'ibindi byinshi bitandukanye turi burebe kuri switch ya relay. Nimucikwe n'iri somo, it is very important for you. Thank you. Today we are going to study one of passive component which is called the relay. We will see relay, what is relay, what is the working principle for relay. We will see the image and the symbol of relay. So let's start by definition. A relay is a simple switch that prevents a bigger circuit from damaging. It works as an electromagnetic switch which gets triggered when a small amount of current flows through it. A small amount of current in the relay creates a magnetic field around the coil which is then used turning on and off a large amount of current. Simply, you understand that the relay, it has two parts. It has electronic parts or electrical parts and mechanical parts. In electrical part, there is a small amount of current flowing through the winding or through the windings of it, and that small amount of current, it creates magnetic field around the coil. Then that magnetic field attracting or turning on and off the large amount of current. That magnetic field starts to control mechanical part of a relay. You see, this is a image. This is the image of a relay. Then this is a symbol. So you can ask yourself, what is a relay? We saw above, it is a passive component which has able to make a switch, or it can switching by using this few theory we saw above. Then a relay is an electromagnetic switch that is used to turn on and turn off a circuit by power signal. You see, or where a several circuit must be controlled by a signal. So we know that most of higher end industrial application device has a relays for their effective working. Relays are simple switch which are operated both electrical and mechanical. You see, we talked that above. It has both two parts. There is part of electrical or electronics, and
a part of mechanics. Relay consists of an electromagnet and also a set of contacts. The switching mechanism is carried out with the help of electromagnet. There are also other operating principles for its working, but they differ according to their applications. Most of the device has application of a relay. You see, relay iba ifite igice kiri electric n'igice kiri mechanic. Hanyuma iyo flow of current cyangwa se iyo hari voltage applied on the winding part, or iyo hari voltage zapplyinzwe kuri electrical part ya relay, bikora icyo bita magnetic field cyangwa se magnetic, bikora sumaku, ibyo mu kinyarwanda twita sumaku. Iyo sumaku niyo itangira ku controllinga za contacts, igatangira ku manipulatinga cyangwa gukontorora mechanical part of a relay. So why a relay used? This is the second question we are asking. The main operation of a relay comes in place where only a low power signal can be used to control a circuit. It's also used in place where only one signal can be used to control a lot of circuits. The application of relay started during invention of telephones. They played an important role in switching calls in telephone exchange. They were also used in long-distance telegraphy. They were computers. They were also used to perform Boolean and other logic operations. The high-end application of relay require high power to be driven by electric motors and so on, such as relay are called contactors. You see, relay muri tekinoloji ya kera yabanje mu gukoresha telefone niho zatangiye kugaragara cyane mu buryo bwo guhuza imirongo. Ubu muri iki gihe dufite high technology, turi muri tekinoloji yihuse cyane, ariko mbere telefone kugira ngo zihamagarane habagaho mechanical connections cyangwa se guhuza imirongo ibiri hakoreshwaga za relay. Iyo tekinoloji nayo yatangiye gukoreshwa muri calls in telephone exchange. They were also used in long distance telegraphy. No muri telegraphy zakoreshwagamo. Ni ukuvuga ngo urumva umumaro wazo ziri more advantage kuko zibasha gukoresha electrical parts na mechanical parts. Murumva ko zaje kera zakoreshwaga muri telephone exchange. Then relay design. There are only 4 main parts in relay. They are electromagnetic, movable armature, switch, point, contact, and spring. The figure is given below show the actual design of a simple relay. This is a control coil. This coil is the one when the voltage or the small amount of current flow through this coil produce the electromagnetic, which with movable aperture. This is a part of movable aperture which will be attracted on the magnetic field will be applied on this iron core. Then switch contact. This is a part where the all mechanism start to be applied. You see, iyi control coil ni ya bobine yinjiramo a small amount of current. Then iron coil ni hahandi iyo twamaze ku applyingaho hano ya small amount of current ihita ihinduka nka sumaku ikabasha gukurura cyangwa se gufata iyi movable aperture. Then iyi yifashe iyo donc igenda ifata ikarekura. Turaza kubibona neza mu tundi dushushanyo. Iyi switch contact no kuvuga ngo iyo iyibashije kumuvinga donc ifata kuri ya sumaku ikanarekura. Akangaka niko gakora nyirizina switch contact point, niko kagenda gafata kakanarekura. Turaza kubibona hepfo. Relay construction. It is an electromagnetic relay with a wire coil surrounded by a nylon core. A path of very low reluctance for a magnetic flux is provided for movable armature and also switch point contacts. The movable armature is connected to the yoke with its mechanically connected to the switch point contacts. These parts are safely held with the help of spring. The spring is used so as to produce an air gap in the circuit when the relay becomes de-energized. Ahangaha bari gusobanura kandi twavuga gara hejuru ko movable part habamo na za mu kinyarwanda babyita rasoro spring ifasha kugira ngo mu gihe sumaku yabonetse cyangwa se mu gihe twapplyinze small amount of current in our winding cyangwa se in our in our control coil ya sumaku ifate, then mu gihe small amount of current twayikuyeho ya sumaku isubize ya switch contact in a normal position kugira ngo ibashe kurekura. Iyo spring ni idufasha gukora air gap. You see, we will see in previous session. Now, how relay works. Now we are going to see how a relay works. The relay function can be better understood by explaining the following diagram given below. You see this diagram from power source. You see from power source, then this is our control coil. You see, we saw above, this is a ground, this is a source of power. When we apply this, you see this, our winding or our control coil is on iron core, is winded on iron core. So you see there's our contact open. You see this? There's two contacts. Then let's see what will happen when we apply this power source on our winding. You see, this winding, the flow of current will produce the electromagnetic. This electromagnetic will attract this metal or this contact above it. When it attracts it, this point will be connected with this one. You see, the power source, when it is applied on this coil, the iron core will produce magnetic field which will attract this metal, and this metal will attracted to this iron core and attracted to the contact open. This contact is open while, but if we connect this voltage, our contact will be closed. You see, mu gihe tuzashyiraho izi small amount of current, zizaza zitume iyi bobine yacu ikereya sumaku cyangwa ikora magnetic field kuri iyi iron core yacu. Icyo gihe akakuma kayiri hejuru kazahita kamanuka kayifateho kuko izaba yahindutse sumaku, then nikaza kakayifataho. Urabona izi contact zacu ziri open, aka kazahita kaza gakoreho hano. You see, let's read this. The diagram shows an inner section diagram of a relay. A nylon core is surrounded by a control coil as shown. You see, the power source is given to the electromagnet through a control switch and through contacts to the load. When current starts flowing through the control coil, electromagnetic start energizing and thus intensifies the magnetic field. Thus, upper contact arm start to be attracted to the lower fixed arm, and thus closes the contact, causing a short circuit from power load. On the other hand, if the relay was already de-energized when the contact were closed, then the contact move oppositely and make an open circuit. As soon as the coil current is off, the movable armature will be returned by a force back to its initial position. This force will be almost equal to half the strength of magnetic force. This force is mainly provided by two factors. They are the spring and also gravity. Relays are mainly made for two basic operations. One is low voltage application and the other is higher voltage for low voltage applications. More preference will be given to reduce the noise of the whole circuit. For higher voltage applications, they are mainly designed to reduce phenomenon called arcing. So, aha twari turi kureba how a relay will be working while we apply that small amount of current. Relay basics. Basic for all the relay are the same. Take a look at pin 4 relay shown below. So let's jump this. It is not needed. So a relay application. Let's jump to relay application. A relay switch is used to realize a logic functions. They play a very important role in providing safely critical logic. Relays are used to provide time delay functions. They are also used to time and delay open and delay closed of a contact. Relay are used to control high voltage circuit with the help of low voltage signal. Similarly, they are used to control higher current circuit with the help of low current signals. They are also used as protective relays. By this function, all the faults during transmission and reception can be detected and isolated. You see, those are main 4 application of a relay. We will do different circuits practice of a relay. You will see these applications where we can use a relay for controlling high voltage circuit with the help of low voltage. We will see this or in our next session. So thank you for attending these courses. A relay is one of passive component which is very important in daily life of electronicians or electricians in their implementation of their project. So let's meet again in practice of them.